Hi there, and welcome to Kusto Query Language, the next query language you will learn to manage Azure SQL databases, or in fact, anything in Azure. Hi there, I'm Hamish Watson. It's a real privilege to be speaking at DPS 2020 this year. Even virtually, I'm really happy to be a part of this wonderful event. I've been working in IT for a wee while, 8,047 days. I'm a director on multiple education and community boards. Education is a passion for me. I really like helping people learn. I'm a Microsoft Data Platform MVP. I love data, I love Azure, and I love DevOps. They're passions for myself, and they're also passions for my company as well. I'm a friend of Redgate. Redgate do some fantastic products in the DevOps space for databases. Basically, over the course of my career, I've realized I am a technologist who understands business value because every action we do within our database or in our platform delivers business value to our clients. So today, I'm also going to be on the chat application, so feel free to message me during the session. You basically get double the Hamish. Alrighty, the agenda. I'm going to be talking about what Kusto query language is, where it's used, how it relates to Azure Data Explorer, and there's going to be a lot of demos. So, what is Kusto query language? Well, you can short it to KQL or KQL, whatever you want to call it, I don't mind. It uses a Kusto engine to query big data sets. And specifically, data sets that are related to all the things or offerings in Azure. Using KQL, we can quickly analyze Azure logs to look for trends, issues, and any insights into what is going on with our Azure applications, services, whatever, resources. There we go. Currently, we can use the Kusto query language on multiple platforms within Azure. So, one of the things I will be looking at today is using log analytics. So basically taking my resource, connecting it up to log analytics, getting some diagnostic data flowing through, and then querying it. Log analytics allows us to manage our Azure resources as well as on-premise environments. It basically allows us to get insight across all our systems to look at what is happening so that we can, maintain their availability and also scrutinize their performance. Application insights is more sort of a developer related thing, but it's key to maintaining the uptime of our resources and understanding what's going on. And basically, it's an extensible application performance management service that Azure and Microsoft offer that basically allows us to build and manage our apps on multiple different platforms. We also have advanced threat protection within Azure, and this allows us to have a unified view of what is going on with our resources so that we can do preventative protection. We can detect if there have been breaches. We can automate some of the investigation and also start doing some responses around it. And this ties in with Azure Security Center, which again, Microsoft have brought in a sort of a unified view of all our resources. And the really cool thing is that when I query across all these platforms using KQL, it's the same experience. It's the same, query language I'm going to use. It's identical across them. The only real difference between, log analytics, application insights, advanced threat protection, and Azure Security Center is basically the data underneath. And if you have already learned SQL or structured query language, picking up Kusto query language is going to be really easy. And the really cool thing is Microsoft have given us some demo platforms that we can use, and I'll be talking about those soon. And the demos, a key part of them will be using those demo platforms. So it's a really cool place where we can practice KQL. Alrighty, so I use Azure. I use it daily. In fact, I use it hourly. I use it to help my clients build out data platforms. I help them build platforms. It's a key part of any DevOps pipeline, being able to provision resources really quickly. But it's all very well provisioning resources, but we need to actually know how we can monitor and manage them. And basically, Microsoft have brought all of the monitoring and everything into Azure Monitor, which is a really awesome unified view across all our systems. And basically, you know, at the left-hand side of the slide, we have various sources of monitoring data. You know, we look at the application, the operating system, resources, even our subscription tenant, and we can even bring in custom sources. Basically, we populate each of the data stores, and so we might populate the metrics, so we're interested what's actually happening with our resources, as well as the logs, so analytics, log analytics. And basically, you know, we bring these in, we get insights, we can visualize things, we can create a whole heap of dashboards, and doing a whole heap of analysis. And as I'll show in the demo, we can actually respond according to the data that we have brought in. And the really cool thing is Azure Monitor uses a version of Kusto query language that's also used by Azure Data Explorer that's suitable for simple log queries, but it also includes a whole heap of advanced functionality, you know, such as aggregation, joins, and a little bit of smart analytics, so that we can really build out some diagnostic information on what is occurring in Azure, as well as on premises if you've hooked that up to Azure. So it's free to try out as well. So there are a couple of URLs here that you can go and you can try out log analytics, application insights, and advanced threat protection. You do not need an Azure login or subscription. You just go to the website, jump in, and try it out. So, as I mentioned, today I will be using some of these to do the demo, because that way, you know, if you're new to KQL, then you're going to see some of the same stuff that I've done. So, I really wish I had known about this cheat sheet. So I've been writing in KQL for probably about 2 or 3 years now. And it was a little bit of a learning curve for me because I had to think a little differently. But Microsoft have put out a cheat sheet, and it's awesome because what it does is, you know, select star from dependencies. If I want to select all the data from my dependency table, this is how I'm going to write it in SQL. In KQL, we just write dependencies. That's basically going to give us the whole data in that table. Let's say we want to be a bit more selective because we write better SQL than select star, right? So I might select name and result code from dependencies if I'm doing this in SQL. Whereas in KQL, what I'll do is I'll take the dependencies table, I'll then pipe it out to name and result code. Now you'll see the word project. Basically, project tells us which columns we actually want in our result set. So again, narrowing it down. We can also group and do aggregation. So in SQL, I might select my name, I'll do the average for the duration column from dependencies, and I want to group by name. In KQL, we basically take dependencies, we pipe it, and we summarize the average duration by name. Alrighty, you've heard me talk about it, and I'm only going to just kind of touch on Azure Data Explorer today. It is not even one session. If we talked about Azure Data Explorer, it's going to be a whole day. But the really cool thing, it is a fast and highly scalable data service that allows us to grab log and telemetry data. And the reason why I'm including it today is because it uses KQL as the query language. And I've been working with clients ingesting a whole heap of data, and it helps it helps my clients handle the many data streams, emitted by their software or applications. And what we do is we collect, store, and then analyze that data. It's really ideal for analyzing large volumes of data, which is quite diverse from basically any data source, as you can see on the left there. Websites, applications, IoT devices, you name it. This data is used for diagnostics, monitoring, reporting, machine learning, and additional analytical capabilities. Azure Data Explorer makes it simple for us to ingest the data and enables us to do complex and ad hoc queries on that data in seconds. For me, it's a game changer, but it's also an enabler because I've started doing machine learning stuff that I never thought I'd actually be doing. The advantages of Azure Data Explorer is that it scales quickly to terabytes of data in minutes. And it also allows us to do rapid iterations of data exploration for revealing, insights. And the key thing here is we're after the insights. We get all this data in and we need to, get some really good analytics out of it. The key thing to remember here is a query in Azure Data Explorer is a read-only request to process data and return the results of this processing. We don't modify the data or metadata. And the really cool thing is it's really easy to refine our queries, and Azure Data Explorer is built to scale, and basically it makes the process easy to refine our queries because it is so fast with doing our ad hoc queries. As I mentioned, Azure Data Explorer handles a whole heap of different types of data. It can be structured, semi-structured, that JSON thing, or even free text or unstructured data. And it just treats them equally well. It allows us to search for specific text terms, locate particular events within our data, and get metric style calculations on structured data. I feel like Azure Data Explorer is this fantastic bridge between the worlds of unstructured text logs and structured numbers and dimensions. And it just means that data exploration is now simplified by combining fast text indexing, and time series operations. I'm really looking forward to more and more people looking at Azure Data Explorer because for me it's been a wonderful game changer. Alrighty, I've talked a whole heap. Now what we're going to do is do a whole heap of demos in Azure looking at KQL. So let's get into it. Okay, so for the first bit, what I'm going to do is actually show you how to set up log analytics in Azure. So I'm in the portal here. So what I want to do is add a resource. I'm going to look for log analytics. And we're going to create a workspace because this is where we're going to send our data to. So I'm just creating a resource group that I'll put it in. Let's call this, I don't know, demo DPS. Done. I'll put it somewhere close to most of my resources. There's no point putting resources, that are in, say, Australia East and putting my log analytics in, I don't know, West US, so that all that traffic has to cross the Pacific. Anyway, I'm just going to accept the defaults here. Now, I could spin this up using Terraform, by the way, and if any of you want to learn some, infrastructure as code, there's some great sessions at DPS. I could use ARM templates to create the log analytics workspace. I just thought I'd show you just a way of doing it through the portal. So we'll let this bubble away. And then what we'll do is add in some logs for one of our resources. Cool. That was pretty quick. Alrighty. So what I'm going to do is I'm going to choose one of my databases. And the key thing here is down here in the monitoring section of our blades, we have diagnostic settings, we have metrics. So, you know, I can run some metrics for my particular databases. There's not going to be too much going on here because, you know, if we do CPU percentage, you know, these are my test databases, so I hardly ever use them. But what we can do is port all of our log data into our log analytics workspace. So we are going to add a whole heap. And you'll see here we can add so much information about our database into log analytics. We can also put that through to you know, a storage account, or even stream it to Event Hub. UAT log analytics. Cool. And basically, I now click Save, and that's now going to put my data relevant for this database into log analytics, and there it is. So what that means is that when I go to my log analytics workspace, I can now query some data. Or what I can do, so there's a couple of ways we can do it. We can do the logs right here and look at things. Or in fact, if we go back to my database, I can actually look at the logs here. So there's a couple of ways of getting to the same place, basically. And you'll see here that we have a couple of queries that Microsoft have given us, you know, average CPU usage, performance troubleshooting, loading data, and wait stats. So, yeah. However, we're sort of jumping the gun a little here, Hamish. We need to slow down because you see right here, this is KQL. So, let's go and have a look at KQL. And what I'm going to do is use one of the demo portals that Microsoft give us, and we're going to run a whole heap of queries and look at how we can get to something like this and get some really awesome data. As I said before, you know, this particular database is not heavily utilized. I literally just spin it up and do some stuff and then throw it away. So there are actually no results. But let's go and look at some results for other things. Alrighty, so what was it? aka.ms/log analytics demo. And you'll see there, it doesn't matter if you don't use the capitalization, it still takes us to where we want to go. So that's all good. And as I said, you don't actually need to have a login to Azure, which is pretty cool. So here we are, log analytics. And you'll see here on the left-hand side, there is a whole heap of solutions that Microsoft have given us. What we can do, we can look at things by category. So, you know, Azure Monitor, IT and management tools, what have you. Or, that's the solution, resource type, right? So look at all this. This is all the things that we can query in Azure, right? Using KQL. So let's do something. So we have scoped our queries. We're going to use the demo solution that Microsoft have given us. So our first query, I want to look at perf stuff. And you'll notice here that KQL in the portal, gives us, you know, that sort of IntelliSense type thing. It gives us a couple of recommendations. Now there's two ways I can run my query. I can click run, or I can use Shift Enter on the keyboard. Now, I'm going to get a lot of data here because as you saw before, this is the equivalent of select star. And so this is limited to the first 10,000 results, right? Because I've literally said for the last 24 hours, just give me everything that, you know, Microsoft have in their perf table, and, you know, just give it all. What we can do, we can actually go out to 7 days, 3 days, 48 hours, you know, last 30 minutes. So if we ran this, hopefully it's going to be a little bit quicker. Hopefully. And you'll see here, we still have 10,000 results because it's limited to them. So there is a whole lot of stuff. One thing I'm also going to tell you about the portal is we have Query Explorer, and you'll see here that Microsoft have saved a whole heap of queries that we can actually use and have a look at, which is pretty cool. And there's some solution queries. So the thing is, often when I'm writing queries, I will actually, or I'm trying to think of how to write something, I'll actually look to see if there's a saved query that other people have done, if there are solution queries, before I actually get in there and start digging around. So what I want to do is actually limit what we're actually going to look at. So I'm going to say, let's search for, so we're going to pipe out to search for memory. So what I'm doing here is I'm limiting it down to the object name called memory. And you'll notice here now we have 676 records, and it took about 2.5 seconds. So that's pretty cool. What it does mean is that we can also search using wildcards. So, you know, give me things that have bytes in it. I might extend this past the last 30 minutes, but that's okay. So yeah, you'll see here our counter name has bytes, write bytes, megabytes. So this is pretty cool. We can do, you know, wildcard queries just the same as we do in T-SQL. So I've been using search, but what we're going to do is use where, because this is one of the operators where we can narrow down our query down to what we actually want. So we're going to say the time generated field, you know, greater than or equal to about an hour ago, and we're saying our counter name is bytes received per second. So let's run that. Oh, it helps if I click in the right place. Just, you know, read the error as normal. It's pretty informative, and at worst, you know, that's why Google was invented. So the really cool thing is I can actually put in multiple ands, right? So I want to know where it's bytes received per sec and the counter value is greater than 0. Now I could again just hit Shift Enter there, and here we have it. You know, we've got 2025 records. What I can do is, you know, I can change this to local time if I want. I mean, one of the reasons why we have UTC is because a lot of what is in Azure is, it's all, well, nearly everything is recorded using UTC. And the thing is, we can do a whole heap of, you know, we can make this, the where clauses as complicated as we want, or rather as complicated as you want. What we can do is use take. And you'll notice here I just hit, tab to auto-complete it. And so what this is doing, take is used to grab a random number of rows from our input data. So I've just said, give me 10. This could be 100, whatever. I can make it whatever I want. I could also, instead of using take, I could do limit and shift enter. And here we go. Boom. So, I have 100 items. Let's do the 10, whatever. So, yeah, limit is very synonymous with take. So, in SQL, we use count. So I'm taking the query I wrote before where I had multiple ands in my where clause, and I can actually count this. So I know that there were 2,028 rows of data that corresponded to where the time generated is greater than or equal to an hour ago, as for bytes received per sec, where our counter value is greater than 0. Cool. So one of my favorite ones is summarize. So what we're doing here, as I mentioned in the slides, summarize allows us to count the number of rows by column using the count function, which we just looked at. And so here we have some really cool information that we've pulled out. What we can do is we can break down this. We're doing counter name here. I could do it by, let's do it by object name. And so, yeah, we get a whole heap of information. This is for Kubernetes nodes and containers, logical disk, you name it. We're just, summarizing this all up. So we can do multiple columns. What we can do, we can actually rename the output column. So let's have a go at that. Where I'm saying perf count, instead of this, we're going to actually label our column to be perf count. And the really cool thing is we can actually use other aggregation functions, right? So let's have a look at one. We're doing free space. We're counting up the number of entries. We're doing an average free space here where we're doing an average of the counter value. So the average free space is, 82.99. And again, we're summarizing by our counter name. In this case, we're just doing % free space. So this is really powerful. And what we can do is, one of my favorite things is bin, because that allows me to sort of put our things into time buckets. So I'm going to summarize this, number of entries by, the last few days. So, this is the last 24 hours. What I could do is do the last 7 days. Let this run. And there we go. So we can, do a whole heap of summarization across multiple days by using the bin function with the time generated column and putting this out into 1 day increments. What I could do, and let's do this, I could actually do it, 15-minute increments, which might be a lot of data, but that's okay. And here we go. So we're doing it in 15-minute increments. Really powerful, but more importantly, really easy. Okay, we might want to do a couple of functions. So we have the extend function. So here basically saying we're going to do a calculated column, and we're using extend to calculate 3 gigabytes is our counter value divided by 1,000, or it could be 1,024 if I was doing this properly. Anyway, we now have this column here, 3 gigabyte, which we have calculated using the extend function. Alrighty, I'm going to talk about the project function, which I have mentioned before. And basically, project allows us to select a subset of columns. So, you know, instead of doing perf, which is basically select star from perf, I'm actually going to narrow it down to this subset of columns. We'll let this run. And here we have it. You know, again, we've got a lot of results. Let's, I don't know, do the last 30 minutes. And still a lot of values, but that's okay. The really cool thing is we can actually combine project with our good friend extend. And run this. And so what we're saying is we have 3 gigabytes, 3 megabytes, and 3 kilobytes. And so again, we're just using extend to generate these. So, you know, the counter value is measured in megabytes, so we'll just do that. But for, you know, kilobytes, we times by probably 1024. Anyway. Alright, so what we'll now do is look at distinct. And so what we can do is use distinct just as we would in SQL. And basically this returns a list of, you know, deduplicated values for the columns in our data set. Cool. So what do we get? 43 records. So if I replace this distinct with our good old friend project, because that's what we want to see. So instead of 43 records, I'm probably going to get, yeah, over 10,000. Because there is a whole heap of duplicated data in there. What I could do is we can use top, which we're used to using in SQL land, and again, you know, we want to look at the top 20 records going by, you know, time generated, and we're doing it descending. Righty, so there is a couple other functions that we can use, and in fact, a really good one is sort. And we're used to this in SQL land. So what I could do is actually just run this part of the query. But by adding in the sort, you know, we can sort out output. So we're doing it by computer and time generated. By default, it will do it in descending order, and we can override that by doing it in ascending order. And we're doing it, you know, greater than 15 minutes ago. So again, some really cool, powerful functions that we can do here. Now, as anyone's probably done once or twice in SQL, we need to format date. And so we're going to take just 100 records, and we're going to format the date, and I need to click properly. And here we go. We have formatted our date. So our first one, time generated, the first one is year, month, date. Then we go year, month, date. And you can see here we can do it right up to sort of the nanosecond type thing. So, another function that would be really powerful for us is between. And again, if you've written in SQL, this should be, quite familiar for you. So what we're doing here, we're looking at a counter name, free space, where the counter value is between 70 and 100. And if we look at our data, here we go. These values are between 70 and 100. So that's all cool. Another one that I've had to use a fair chunk and is similar in KQL is the case statement. So basically where we want to create labels based on values. And so if the counter value is, greater than 10, less than 10 for our free space, it's critical. If it's less than 30, it's danger. And so basically, somewhere in, I think I saw one there. So we have, look at it. And again, our project will just output, computer name, and the free level. So that's all cool. No critical, yep, I think I saw a critical one. There we go. Now what we could do, we can play around. We can do a whole heap of stuff. And in fact, I could have actually just done where my counter value is less than 10. Which will give me the same result. So pretty cool, pretty powerful stuff. Now what if I need to do some if then else? Well, we can do that in KQL. And we have IIF. So, if the counter value is less than 50, it's going to output, you might want to look at this, else it's going to say, you're okay. Just wait for this. So, for the majority of these, we're okay. Oh, there we go. You might want to look at this. So again, we can use the if statement to really build out some awesome queries that are, again, going to give us some awesome insight. We can do some other functions. So what we're doing is we're going to use isEmpty. So basically, if our instance name is empty, we're going to output there's no instance name, else we'll output instance name. And we're doing it for the past hour. Cool. So most of these have an instance name. What we could do is use our good old friend count and see how many there are. Whoa, there's one or two that have an empty instance name. So yeah, isEmpty will match on empty text strings. So let's move on. I've come from a sort of scripting background, and I use variables. So we're going to use some variables, and we're going to use let. Basically, let allows us to have a constant value. So we're saying let our min counter value equal 300, and let our counter name equal 3 megabytes, and we can run this And this might take a wee while because I'm doing it over the last 24 hours. In fact, let's cancel this. Still lasts 30 minutes. And that's another thing. If your query's running, just hit cancel and we'll run, the query again. Whoa, there is a lot of data. I think what I'll do is we'll move on to another one, but you get what I mean. But the really cool thing about let is I can use it multiple times in our query, basically making it easier to operationalize our query. So we're saying let comp name equal this. I might do last 24 hours. Computer equals the name that we have there, and we're building up our string. So let's run this. And here we go. So you'll see here, I've built it up using the comp name, which is really awesome. And what we can do is actually use let to hold calculated values. Right. So I'm saying let the start date equal 12 hours ago. And you'll notice here that the time range is set in the query, and here we have it. A whole heap of data. So, when I first started writing SQL, I had to learn all about joins. And we can do joins in KQL. Basically allows us to join two tables together when they have a common column name. So, we are going to join Perth with the alert table, and they will join on the computer column name. And so here we have it. We have the Perth information here, and then over this side we have all of our alert information. So that's pretty cool. And again, I could use, pipe this out and use project to select what columns I want. So that's pretty cool. What do we do if we don't have a common column name between them? Well, what we can do, so Perth and alert do not have, let's say they don't have a common column that we want to use, then we go left, i.e. Perth dot computer equals right. So this could actually be, I don't know, this might have been called computer name or something in the other table. So this is a cool way where we can actually join tables that don't have that common column. Alrighty, so as we all know, writing SQL, joins can get pretty complicated. So, you can build this out to however you want. So what I'm doing here is, I'm doing a join on the alert, and this is, we're going to get pretty complex pretty quickly, depending on what we need to do. And so join supports many types. We have, the default is the inner unique join. So here, this one is actually an inner unique join. We could do full outer, inner unique, left anti, semi, left outer. Oh, there's no data. Oh, well, that's all right. Left semi, right anti, you name it. There is a whole heap of joins that we can do. So I won't go through every single one. Let's now look at the last function that I think you'll need is union. So if I just ran this is the update summary. So this tells me the update summary for our servers or resources, right? So here we have Windows, whereas this table update tells me, you know, what is actually going on in there. So this will have a whole heap more information. So I can do a union. You know, a join of A and B will give me, you know, A dot column 1, A dot column 2, B dot column 1, B dot column 2. Whereas when I do a union, it's going to give me, you know, the whole lot. So I'm going to union these, and basically it's a combination of the two tables, right? Pretty simple. And here we have it. We have a whole heap more information that we're pulling from both tables via the union. And what we can do, we can actually build this out, you know, add a column, you know, this is called source table, to indicate which table it came from. So that's pretty cool. If we do that, we're going to actually have, it's going to tell us, you know, where these came from. So update summary, you get it. Okay, so that has been a relatively quick introduction to KQL. As I said, you can build as complicated queries as you want, and like I said, you know, there's a demo portal that Microsoft have put up. We've been doing log analytics because that's kind of my favorite to give me insights into what's happening. There's the application insights one as well. You know, I want to see what's going on in my app services and what have you. So I could use app insights and start, you know, using KQL again. You know, I'm using the same language, but in multiple things in the Azure platform, as well as, you know, the advanced threat protection. I can also use it there. Cool. Okay, I know what you're saying. Why have I been doing all this, you know, Azure resources stuff, Hamish? We're data professionals. Show us some database stuff. So here I have a pretty intensive running system. We've got some databases here that are pretty busy. You know, they've got some stuff going on. And so what I can do is actually use, you know, log analytics, and we can write some queries as we want. And so what I want is I'm going to grab Azure metrics. I'm going to say where my metric name is CPU percent. And I don't want everything, so I'm going to project. I want time generated. And the cool thing is, KQL will give me exactly the columns that are relevant. I want my resource and the average. Cool. So what we can do is actually get, you know, the CPU average for, in this case, the last 30 odd minutes. What I could do now is, in fact, I could graph this out. And I get a pretty cool graph, right? So this is the last 30 minutes. And I could do a whole heap of stuff with that. But the really cool thing for me, right, so if where the average is greater than, I don't know, 5. Oh, let's go with 2 and pretend this is like 20%. It's the worst thing in the world. Okay, so we have one time in the last 30 minutes. Well, let's go with the last 24 hours. Okay, so if we look at the average, and in fact, what I should do is project time generated average. Run that. Cool. So we've had, 222 times this has gone over 2%. Let's see over 5. Now we might have a threshold of 5. This might be really bad. This is where it all comes together. We can now create an alert rule from our query. In fact, I don't need to project that there because the query doesn't need that. But what I can now do is use some actions. I can do, major production alerts. I can put it to teams. I can do a whole heap of stuff. So I can build an alert based on the query that I've run in Log Analytics. And that, my friends, is the power of KQL. We're bringing data into Log Analytics, and now we can create actions. We can alert on it. That's brilliant. Alrighty, let's go back to the slides. Okay, as mentioned, we're going to look at an Azure Data Explorer cluster. So I've built one here in Azure Portal. I've called it Hamish ADX cluster. You do have to have a unique name, so just be aware of that. I've built it so that if it needs to scale out, right? So if the performance hit from my queries is too great, it'll actually scale from 2 instances within my cluster out to 8 instances in my cluster. But I got to be honest, I don't think that we're going to put this under too much load. I've created an empty database. You'll see there it's 0 bytes. I've given it a retention period of 365 days, a cache period, some really cool things. Anyway, the main thing here is we're now going to connect to this and we're going to ingest some data, and we're going to run the Kusto query language, or KQL, over it. So let's now jump into Azure Data Studio. Okay, so here we are in Azure Data Studio. I have my cluster here. We have our database that I created before in Azure Portal. So let's do a query. The really cool thing about Azure Data Studio, if you haven't used it, is it has some pretty cool IntelliSense type stuff. So that means I only have to type a few letters and, push tab, and I can get what I need. So we've got show database here. It tells me my database name. It's a bit of persistent storage. As with all databases in Azure, it's version 12. So yeah, some really cool details there. But what we actually want to do is create a table in our database and ingest some data. And so what I'm going to do is I'm going to create a table, storm events, and we are going to create this and actually use some of the data that is on the internet that Microsoft have provided in one of their tutorial type things. So if we refresh this, we now have our storm events table with, all of our attributes and everything. So that's pretty cool. But what we need to do is actually ingest some data in there. So I'm going to go out and get some from some blob storage that Microsoft have given us. And so what I'm doing here is I'm ingesting into my table storm events from the Kusto sample files, which are in blob storage. And so let's now chuck that in. That will take a wee bit of time because it's going out to the internet, grabbing the data and then putting it into our table. So should take about another 3 seconds. But this is pretty cool, right? So we've ingested the data into our table, and what we can do is, I talked about before, there's some simple commands in Kusto. We can do a count. So, 59,066 events in our database. So basically this is giving the rows in our table, so that's pretty cool. What we can now do is build up some queries that we're pretty used to using in good old SQL land. So what we're going to do here is use our where statement and looking at where the event type, because these are storm events, where the event type is a flood, the state is California, and we've put in some date time attributes. And basically, if we run this, we should get, one particular record where, there's a frontal system, blah, 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 blah. So we can use, we can filter our data because, there was 59,000 odd rows in there. And we can filter it down using good old where. So you'll see the pipe command. I showed you this before in the Azure portal. So this is really where we can use Kusto query language within Azure Data Studio against the Azure Data Explorer cluster. Okay, so let's have a look at some data. What if we could take a random sample of 5 rows? And so we use the take command, and if we run this, it basically gives us, a random sample of 5 rows. Basically, take shows rows from our table in no particular order. So what we can actually do is use some other commands that we're probably used to, our good old top. And again, what we're doing here is we're using the project operator to show the different columns that we want to produce in our output. So here we go. So we've grabbed the top 5 records, and we're using project to say we want start time, end time, event type, state, and event narrative. So again, these are all storm events. What we can actually do is actually achieve the same result by using sort and take. Right. In fact, let's put these right next to each other, and we can actually see these run together. And you'll see here that we have the same output, which is pretty cool. Alrighty, what should we do next? Well, when I've been doing stuff with SQL Server, I've had to, create new columns, and these might be computed columns. So let's do the same. We're going to use the extend, right? So I'm saying that duration is going to be my computed column, where end time minus start time is my duration. So let's now do that, and we only want 5 rows back, so we're going to limit to that. And you'll see here that we have our duration. So it's pretty cool. We can create a new column, do some really cool things there. Okay, so let's say I want to look at the particular states in the US where this data is from, and I want to summarize. So again, I take my table, I pipe in the output of the table into summarize, which basically will count the number of events occurring in each of the states. So let's have a look at this. And we now get an event count for the particular states and what have you. So we can start doing a whole heap of aggregation type stuff, right? And the summarize operator is pretty cool because, we can really build out a whole heap of stuff. So for this one, what are we doing here? We're summarizing our storm count is a count. We're then aggregating things up, and we're using top to, so we're getting the count of the storms in each state. We also summarize the unique type of storm. So, yep, by state, and we're doing the top 5 to get the most, storm-affected states. So here we go. Brilliant. So we're now going to look at summarizing by scalar values. So this is, numeric, time, or interval values using our by clause. Right. So let's do that. So what we're doing now is looking at, we're using a bin function, which basically allows us to have a time interval. So we're saying our bin of or bucket of data is 1 day. So we can now summarize by that. And so, yeah, basically we're summarizing everything into intervals of 1 day. So we're bringing all the timestamps again into that 1 day. So that is a kind of quick introduction into both Azure Data Studio as well as Azure Data Explorer clusters, which is really awesome if you're ingesting a whole heap of data. I ingested it just from blob storage, and then we can use KQL to create some really cool queries that are very similar to what we do with, say, SQL Server, but of course this has a whole different use case. Alrighty, well, hopefully that has shown you a whole heap of cool things about KQL, and you're just really ready to go out and try it out. Alrighty, it's really easy to learn, and it's really powerful. And basically, if you do anything in Azure, use log analytics and app insights, connect your resources up so that we can monitor them and manage them and know what the heck is going on. Microsoft is using KQL more and more. So should you. And as I mentioned, it's a really good introduction into machine learning capabilities. There is a whole heap of stuff that you can do, and I think that it's a good introduction to getting on board with machine learning. So we got question time now. As I mentioned, I'm in the chat somewhere, so hit me up with some questions. I really look forward to answering them and engaging with you. And as always, a special thanks to Microsoft. Thank you so much for supporting Data Platform Geeks and SQL Server Geeks community initiatives. It is so awesome, And thank you. Thank you for coming along to my session. There's 3 ways to win prizes. Post your selfie with a hashtag. Give session and conference feedback. That is vital for us to do this better. And visit our sponsors and exhibitors. Without them, this wouldn't happen. And of course, follow DPS on Twitter at the Data Geeks and Data AI Summit. So thank you all very much. Like I said, I'm hanging around, so hit me up with some questions, and have a wonderful rest of your conference. Cheers.